Hey y'all, Aaron here. Before we get started, I wanted to first begin by thanking you all for listening to the podcast. It's been cool to see the stories of how it's been helpful. I think sometimes I'm a little surprised by it actually being helpful, but recently a listener, David, who graduated from a different code school, but recently landed his first job as a software engineer. By the way, congrats to you. Left me this comment that said, seriously, some of these episodes lit a fire that could never be extinguished. Thank you for everything. And those kinds of stories about people, being motivated by what we're talking about here is what's really motivating me to keep going. So we took a couple of weeks of a break for Christmas, but not to worry. We are not going to go through the podcast fade. We're going strong, and we actually have some really cool guests coming up that I'm excited about. Next week, cross my fingers, we're doing the interview this week. Next week, we have a really special guest on, so I hope you'll tune into that. But this week, it is just me again, and we're going to be talking about something that's really close to my heart, which is advice for brand new beginners. And kind of, this isn't meant to be a plug for this Dev 30 program we have coming up, because the Dev 30 program, by the way, is free, but it really does encompass everything that the Dev 30 program is going to be about. So for those of you who haven't heard about it yet, launching on February 14th, we're going to be doing this 30-day cohort-based JavaScript course that's not only going to cover JavaScript, but it's going to cover the other things that you need to do well as a beginner. And that is to get your mindset right, to create good habits, and to start building your network. So you can learn more about Dev 30 at dev30.xyz. That's dev30.xyz. That being said, let's get started with some advice for those of you who are starting this journey. Welcome to the Develop Yourself podcast, where we teach you everything you need to land your first job as a software developer by developing yourself, developing your skills, your habits, your network, and more. I'm your host, Aaron Hayslip, and today I've got 6 pieces of advice for those of you who are first starting to learn how to code. Okay, as I've mentioned in the past before, I have taught countless people how to code from scratch. And I've been doing this full time for about 7 years now. My job has literally been to help people learn to code and land their first jobs as software engineers. So this advice comes from that. It's advice I've given to people who are hopefully in the same position that you are, where they want to become software engineers. There's something about this whole thing, right, that's attractive to them, but they have to get over this really difficult hump of actually learning how to program. And the hard thing is, programming is often different than what you think it is. When you actually get to start programming, it's not what you expect it to be for a number of reasons. And that is oftentimes somewhat paralyzing to people. But I don't want you to get paralyzed. I don't want you to get overwhelmed. I don't want you to become distracted. So therefore, we're going to go through these 6 pieces of advice, which I think will sustain you through learning your first programming language, which, by the way, this brings up advice piece number 1, which is stick to one programming language until you master its fundamentals. Now, I've said this one before, but this is always where I start, which is what should you code? What should you learn first? Now, a lot of people, if you go online to these free tutorials, they start you off with HTML and CSS, which is great. You get this instant feedback loop. You say, hey, change the H1 to red. So you type in red, it goes to red. That gives you a little bit of dopamine, and it's exciting. So HTML and CSS, definitely low-hanging fruit. If you worked hard and you focused, you could learn those things in a weekend, but they are not programming, right? There is no logic involved with HTML and CSS. Instead, what you need to do is you need to tackle a programming language. So stick with one of them. It really doesn't matter that much what you pick, whether it's Python or Ruby or JavaScript. We always suggest JavaScript for a variety of reasons I'm not going to go into right now. But make sure you stick with that first language. Don't go back and forth between different languages because you think this one's better for this or this one has more jobs, etc. It doesn't matter. Learn one first, then the rest of them, if you want to learn more languages, will become 10x easier for you to pick up because you have already established what programming is. And from language to language, programming as a concept doesn't change that much. So you might be asking me, well, Aaron, that's great, but what does it mean to master a language's fundamentals? How do I know when I've arrived? And for that, I'm actually going to put in the show notes Parsity's Admissions Code Challenge. I think right now it's 7 questions in JavaScript. And basically, if you can solve those problems then I'd say you've got the fundamentals down. You may not know more of the advanced concepts like closures and prototypical inheritance and those kinds of things. But if you can put together all the basic parts of the language to solve more complex problems, then you're probably ready to move on. Now, an example of one of these code challenge problems is you have an array, right? Which, by the way, if you haven't started programming, an array is basically a list. And in this list, there are a variety of letters, and some of these letters repeat, and we don't know how many letters altogether there are, but your job is to write some code that can be given any list of letters and return which letter is represented the most number of times and which letter is represented the least number of times. So that would require that you understand functions in JavaScript, arrays, probably objects, a lot of different operators, probably some logic, conditionals, etc. So that would prove to me, for example, that you know the complete fundamentals of JavaScript and you're ready to move on to the more advanced stuff. Now, basically, the rest of this advice I have for you as a beginner is to help you get through this initial part of learning your first programming language. There are some parts in this process that are difficult because you're basically doing all of the work of learning to code without any of the benefits, right? Whenever you learn a programming language, your initial programming language, you're going to have to be learning all the individual parts of the language without knowing exactly how these little parts fit into the bigger picture. So for example, you might spend an entire week learning about arrays without really having any context for how arrays are useful in the real world of programming and what you might be able to do in the future with arrays. Because unfortunately, in order to actually understand how arrays are useful, you have to understand the arrays methods. And to understand methods, you must understand functions. And you know what I mean? It's the logic is sort of circular in the beginning until you learn all these individual parts. So it's going to be difficult to sustain your learning without that feedback loop of actually being able to build something real. But trust me, when you get to the end of having the fundamentals of the entire language, you're finally going to be able to start building real projects, and that is going to be addicting. And hopefully it's game over from there, right? This is the hardest part. All right, advice piece number 2. The computer is dumb, right? It's very dumb. You think the computer is powerful. You look at technology. Technology is amazing, but the computer itself, the code that you're writing, is incredibly dumb. The computer cannot infer what you want it to do. It's not trying to figure out what you're asking it to do. It's not smart enough to do that. The computer has no brain other than the brain that you're giving it. You are basically programming a robot that literally doesn't know how to do anything unless you tell it how to do it. Now, the computer is very powerful, right? It's powerful at small things. It can add huge numbers. It can work with large amounts of data, but it really can't do anything with that data unless you tell it how to work with it. So here are the implications of knowing that the computer is dumb. You have to know exactly what the code is going to do, right? If you find yourself at some point when you're learning to code, trying to solve a problem, and you're guessing, trying to see if it's going to work, just like in math, it's not going to work. A programming language is not like your iPhone. You can't just press a random button and just see what the result is, because oftentimes the result is, well, it breaks everything, right? There are no training wheels in a computer program. So that being said, you need to think about it like programming a very dumb robot. An example of this might be if you're trying to program a robot to make you a sandwich. Not only does your program not know how to make sandwiches, but it doesn't know what make means. It's never even heard of the word sandwich. So the implication of this is that you need to break things down way more than you think you do. And oftentimes in the beginning, you actually end up overthinking problems because you think that the solution is much more complex than it actually is. Whereas it's not more complex, there are much more steps than you think there might be, but these steps in and of themselves are not complex. Now, this analogy might break down, but I'll give you an example here. What if I told you, hey, would you poach me some eggs? The equivalent might be, hey, find me the most frequent item in this array, right? Both of those things on the outside sound complex and difficult. Very few people know how to poach an egg, right? It's really easy to screw it up. Only professional chefs attempt it. Just like finding the most frequent item in an array sounds intimidating in the beginning. But if we think like a programmer, basically this big complex problem is actually a series of very simple steps that we could easily do. So let's start with a poached egg. I have actually been able to master the art of egg poaching. It's not because I become a great cook, it's because I've followed some very simple directions before. And step one of poaching an egg is to buy fresh eggs. Can you buy fresh eggs? Of course you can. Anybody can go into the store and buy fresh eggs. Okay, great. Step two is to boil a pot of water. Can you boil a pot of water? Of course you can boil a pot of water. You just have to put water in a pot and turn up the heat and wait for the bubbles. The next step is to crack your egg into a small bowl, like a little ramekin. Can you break an egg without breaking the yolk? Hopefully. If you can't, well, usually cartons of eggs come in 12. So hopefully one of the eggs you could figure out how to crack open and put the egg inside of this little bowl. Next, can you swirl the water, your boiling water, without splashing over? If not, well, just be careful. I bet with some practice, you could definitely master the art of swirling your water into a nice circle. Next, are you able to carefully pour your little naked egg that's in a bowl into the center of your swirl and set a timer for 3 minutes? I bet if your life depended on it, you could do that one step. And then finally, when the timer goes off, are you able to retrieve that poached egg with a slotted spoon and to put it in a bowl of cold water so that the egg immediately stops cooking? I bet you can. I bet you could easily, if you had these steps broken down and someone told you to do these exact things, I bet you could poach an egg on your first try. The same thing is true with finding the most frequent item in an array. Can you find a most frequent item in an array? Probably not. But the first step is to iterate through an array. Can you iterate through an array? Can you write a for loop? If you've learned anything about arrays, you could probably write a for loop. If you cannot write a for loop, can you look up some code for how to write a for loop? I bet you can. Now, we could keep going with this example, but I don't want to spoil the answer for how you find the most frequent item in an array. But the analogy here is just like with a poached egg, you don't know how to do it because you've never done it before. But if you've worked on the right skills in your life, right? If someone's shown you before how to boil a pot of water, how to open up an egg, then all you need is to problem solve the correct steps, just like with the array. If someone has ever taught you how to loop through an array, how to create an object, etc., then you have all the pieces necessary to solve this big complex problem, so long as you remember that the computer is stupid and you need to break it down into very small, very simple steps. Which, by the way, the best code you could write is simple code. The most readable code is simple code. The most maintainable code is simple code. If it's complex, if it's hard to read, it's hard to understand, it's not good code. That should bring you some relief that nothing in the world of coding is meant to be difficult. Okay, so you're sticking with one programming language in the beginning. You're reminding yourself that the computer is dumb. You're breaking everything down into small, simple steps. And you're realizing that all of coding is basically just very small, very simple steps. My next piece of advice is very practical, and that is code with the debugger. Learn how to use the debugger. Now, in JavaScript, this is the Chrome Developer Tools. If you've learned how to use the debugger, then you'll never again guess about how things work. So if you've written some code and you're not getting the result that you expected to get, it's time for you to dive in and figure out exactly why you're not getting that result. And with the debugger, you can literally pause the code as it's executing. You can get in and look around. And my goal here, whenever I'm debugging with the debugger, which by the way, you're not gonna learn how to do that in this episode, but basically go online and find some tutorials for this. My goal here is to test all of my assumptions. Usually what this means is I've assumed something is doing something, right? I've assumed this variable is pointing to this value at this point in the code, etc. And it's not actually doing that. So I need to verify any of the assumptions that I'm making. And oftentimes what happens here is you're making a silly assumption about something that you think you would have figured out long ago. And those are usually the best and worst errors you could possibly get, which are, oh my goodness, are you kidding me? Like I just forgot to close that bracket, or something that's so silly that you could do it in your sleep, makes you feel dumb in the moment, but also makes you feel smart that, hey, there's nothing here that's crazy over my head that I couldn't have figured out eventually. I just wasn't breaking things down small enough. I was assuming that I was doing things more correctly than I actually was. So use the debugger, actually know what the code is doing, and test all of your assumptions as you code using the debugger, the Chrome developer tools. If you're in JavaScript or whatever language you're using, there's always some kind of debugging mechanism available to you. And this brings me to my fourth piece of advice, which is focus on reading code and knowing exactly what's going to happen to the code that you're reading, right? Never guess how it's going to work. Know how it's going to work. Again, focus on knowing how to read code. So one way to do this is to understand how the compiler or the engine works with whatever language you're using. So in JavaScript, there is this JavaScript engine. If you're using Google Chrome, it's called the V8 engine. If you're using Safari, it's WebKit. But basically, they all operate similarly in terms of how they evaluate JavaScript. One of the things that we do at Parsity is we go over how variables are compiled and assigned. And the order in reality is actually a little bit different than you might think intuitively. But if you can learn that, then you can learn how to read any piece of JavaScript. And if you can read any piece of JavaScript and know what the outcome is going to be, then you can ultimately write any JavaScript, because the more you can read, the more you can understand, and the more you can prove to yourself that all of coding is knowable, right? Let me say that again. All of code is knowable. If you are inside of a code base and you're reading some code, all of that code that you see there is knowable. You can learn what's going on. And if it's written in a language that you understand, a language that you're familiar with, and you've written some code in that language as well, then with just a little bit of effort, you can understand how that code is working. And in the future, write something similar if you evaluate it to be good code. So for example, if you're starting a new job at a company and you're looking at some JavaScript code that you've never seen before, that you're not familiar with, if you know how JavaScript executes, then you can start where the code starts, right? There's always some kind of starting point where the first file gets loaded, the first functions invoked, etc. You can find that starting point and you can follow the steps the code takes. Maybe it's based off of what a user does, based off of page loading, basically the different events that happen that cause other functions to fire, etc. Now, in that process, if there's something that you don't understand, if there's something that's unfamiliar, something new, probably it's from a library of some kind, right? Some kind of JavaScript library that you're perhaps not familiar with, which is great. It just means that somewhere there's documentation, and that documentation for that library, its main purpose is to help you understand how it works. So there might be new things that you have to learn, but again, it is knowable. If you learn how to read code, then you will ultimately be able to learn how to write any code. All right, so to review so far, advice piece number one was to stick to one programming language. Number two, the computer is dumb, so break down problems more than you think you might need to. Number three, learn how to code in the debugger and test all of your assumptions. Number four, focus on learning how to read code and never guess about how code works. Number five here is to write a little bit of code and then test it, right? So always be testing. Now, I'm not talking about test-driven development, which you might have heard about. Hopefully in the future, you will learn about how to actually write tests. But what I mean is, in the beginning, when you're learning to code, you're going to be writing small amounts of code to solve small problems. Test what you write frequently. Don't assume that you haven't made any mistakes. Oftentimes, this happens to beginners. They start coding, they need to write a bunch of code. They go to evaluate it or run it in the console, and they get a bunch of errors, and they can't figure out why the errors are there. And it's probably because the error message is maybe unhelpful, because your error happened, 5 or 10 minutes ago. So my suggestion here is to write a small amount of code, and whenever you think you've got something worth testing, go test it. And by the way, worth testing is if you declare a variable, make sure that variable points to what you think it should point to, then test it, right? Just go back and forth. I always set up my screen, for example, if I'm writing JavaScript and the browser, where I've got my browser in one window, I've got my text editor in the other, and I'm constantly just coding and refreshing to see in the console if there are any errors. So for every single line of code I write, I test how that code will be evaluated in the console so that I don't end up with a bunch of errors that are difficult to find. Okay, that one was pretty straightforward, but not necessarily intuitive for beginners. And then finally, number 6 here in my pieces of advice. I don't know why I keep saying pieces, but I guess advice piece, advice point, whatever you want to call it. Number 6 is everything you need to write has already been written before. Let me say that again. Probably for the first few years of your life as a software engineer, everything that you need to write in your job, not even just learning to code, but in your job, someone's going to pay you for, everything you need to write has already been written by someone else. Which means your job as a software engineer isn't to create new solutions to new problems, but rather it's to curate proven solutions to problems that others have faced before. I'll give you a couple of examples, and these examples could come from any part of any system, front end, back end, whatever. But I remember early on in my career as a software engineer, there was a joke going around the office that all front end developers at some point have to write a carousel. If you don't know what a carousel is, they're not very popular anymore, but they were basically this slider where you have this image in the middle and you have left and right arrow buttons, and clicking those buttons would cause an animation and things to move in and out of view for the user. And it was often said that every front-end developer has written a carousel at some point in time, and who knows when your time will be. And I remember whenever it was my time to write a carousel, and it was extremely intimidating because I had no idea how to write this carousel concept. What would I even do? But the good news was it had been written before, and I was able to find someone else's code and basically just learn how they did it and implement it. Now, obviously, line for line, it wasn't going to be the same because our use of the carousel was going to be somewhat unique, but all I had to do was figure out how the other person built their carousel, build one that was almost exactly the same, and then make the changes I needed to make in order for it to work. Now, I point all this out, and I even add this as a tip for a couple of reasons. One, I want you to know that maybe coding isn't what you think it might be, at least not in the beginning. You are probably not going to be writing revolutionary code for some new revolutionary technology. Now, it doesn't mean that the company you work for isn't doing really incredible things and pushing the boundaries, and even the code that you're writing isn't part of something that is pushing the boundaries of technology, but probably for a few years, you won't be one of the ones who creates the new stuff. Now, the code that you write is still going to be unique. It's still going to be yours. You're still going to have to understand how it works, but your job is mostly figuring out how to learn best practices and implement those best practices so that it fits the needs of the system that you're working on. Also, I say this here that everything you need to write has already been written as an encouragement. Hopefully it takes a weight off of your chest that no one's asking you to do something that's impossible. No one's asking you to create something brand new that no one's ever created before. What's being asked of you is basically that you learn, and as you learn, you contribute what you learn back to whatever it is that you're building. Now, this isn't just true for a company you might work for. This is true for yourself as well. If you're building your own project and trying to figure out how to do something, it's probably already been done before and figured out by someone else. There's probably an article on the internet explaining it, or a Stack Overflow thread, or some place where you can seek advice on how to do this, or it might even just be in the documentation of a framework. So again, that should give you some peace of mind that you can really build anything. So here again are the 6 things that I want to encourage you with. These are the 6 tips I have for all beginners. 1, stick to one programming language till you master its fundamentals. 2, the computer is dumb, so therefore break down problems way more than you think you might need to. 3, code in the debugger. Test all of your assumptions, no matter how simple your assumptions are. Test that they are what you think they are. Number 4, focus on reading code. Learn how your specific compiler or engine works. Never guess how code is going to work. Guessing will never yield the correct solution with coding. Number 5, write a little code, then test it. Write some code, test, repeat. Never write too much code without testing it. Again, this kind of goes back to testing your assumptions. You never know if you made a mistake or not, so always test your code and see how it runs. And of course, number 6 here, everything you need to write has already been written. Let that encourage you that you just need to learn. You just need experience, and it just takes time. It takes consistency, slowly moving in the same direction for a sustained period of time. It doesn't require intensity. It just requires diligence. All right, that does it for this episode of the Develop Yourself podcast. Hopefully, as you enter into the new year and perhaps enter into learning your first programming language, you take these tips to heart, and hopefully they encourage you to avoid some of the mistakes that I see many beginners make. All right, to learn more about our online code school, Parsity, visit parsity.io. To join our free 30-day cohort-based JavaScript course, which launches on February 14th, visit dev30.xyz. All right, we'll see you here next week.